So finally moving out of our function topic, we're moving away from that and we're now moving into chapter 1, into our trigonometry section. And so it's kind of important to just get a basis and a foundation of what we've been doing. Let's talk about some of the things we probably should already know about trig. So using trigonometry, we can find the horizontal and also the vertical components of a right-angled triangle. Let's say if we have an RAT, again, right-angled triangle, with hypotenuse of 1. So now I'm going to draw an example of a right-angled triangle. We're going to call this angle down here, we'll call that theta. Then we have the hypotenuse of 1, we have an y over here, we have an x there. I'm just using that because x is usually my horizontal axis, y is usually my vertical axis, and so I'm going to keep it like that. Okay, so I could say that that distance y, well, I can find that using trig ratios. I know that the sine of theta is equal to the opposite, which is my y, over my hypotenuse, which is 1. So it equals y over 1, or, so that just means that y equals sine theta. Now talk about x as well, because cos of theta equals x over 1. So I can now say that x is equal to cos theta. That's if I have a right angle triangle of hypotenuse 1. Okay, well, for our unit circle, remember when we touched on the equations of circles being x squared plus y squared is equal to the radius squared? Well, we know that that's because we're always going to have a circle with a hypotenuse from our center. Okay, so if I was to put in my graph here, and let's just make it a bit smaller. Sorry, so here we go. And I'm going to make a point at, that's really not going to work, is it? But 1, 1, 1, 1, there we go. That would be our unit circle, and we'd have a radius every time. Actually, sorry guys, I'm going to completely scrap this because it's a terrible idea. I'm just going to get rid of all this. And just cut it. And I'm going to draw it in. So apologies for that. So I'll draw that. So there we go, there we are, and there we are. And then I'm going to draw, hopefully, what will turn into a circle. That is honestly the best I'm ever going to do it. Oh my god. And we could say that this here is your radius of 1, and then that's your y, and then that's my x. So for our unit circle, we can find the cos theta and sine theta of all of our angles, of all angles from 0 all the way to 360. Because there are 360 degrees on a circle, I could just go all the way around, and I'm going to find my x and my y value for each one. And so I can find a sine theta and a cos theta by each one. Simply by finding the horizontal and vertical components of each degree. So for each value of theta, I can find a horizontal and a vertical component. We are always trying to find the angle, always working with the angle made with the horizontal line. Our reference points are really important when we're talking about angles and our sine of thetas, our cosine of thetas, because depending on your reference point, the angle could be different. This becomes important when working in different quadrants. In different quadrants. So once we have angles in different quadrants, our reference point is always really important once we come to this. Now that we know, spelt with a K, so let's learn to spell. Now that we know that sine theta equals y and cos theta equals x, we can understand the values of sine and cosine in our quadrants. It's really important to consider your 4 quadrants and our sine and cosine of each one, especially when we're going to get into exact values, which is a bit later on. But depending on where our angle is, depending on what quadrant our sine and cosine values may differ. So I'm going to draw in another set of axes, and it's going to be of my Cartesian plane. Okay, so I've got my horizontal line there. I'm going to have my vertical line around about in the middle. No, that was nowhere near the middle. Let's try that one. Sorry. Here we go. Okay. I've got my 2 axes there. And then at the top corner, I'm going to write my... So this is quadrant 1. That's quadrant 2, quadrant 3, and quadrant 4. Okay. We're always going to start anti-clockwise from my horizontal X line here. So we start from here and we go around. Okay. And now I'm going to write sine, cos, and tan in every quadrant. Now for this, it's important to remember that the tangent of an angle is equal to the sine of an angle over the cosine of the angle. And I'll write that at the bottom when I'm done copying all this out. We should already know that, but I'll just write it, not as a therefore, I'll write it as just an important point that we should know down here, that tan equals sine over cos. So we just said that the sine of the angle is equal to y, and the cosine of the angle is equal to x. Well, in my first quadrant, when I'm in that top right quadrant, x is always going to be positive, and y is always going to be positive. So the cosine and the sine of the angle are always therefore going to be positive. And a positive divided by a positive gives me a positive, so tan is positive in that quadrant. My second quadrant, quadrant 2. My sine value, I'm still positive with sine. My y value is still positive. X though, my cosine of theta is now negative. And that will change my tan to a negative as well. Sine and cosine in my third quadrant, my bottom left quadrant, well, they're both negative, and a negative divided by a negative gives me a positive. And then sine may be positive, but cosine, sorry, other way around, cosine may be positive, but the sine is negative, so the tangent is negative as well. All ratios are positive in the first quadrant. Sine is positive in the second quadrant, tan is positive in the third quadrant, and cosine is positive in the last quadrant. All stations to Cottesloe. It's a helpful mnemonic device trying to help you to figure out if they're positive or negative. All stations to Cottesloe, ASTC. Back in my south side of the river, we say all stations to Claremont, but you guys probably don't know what side that is. Okay, so now let's just talk about in summary. If we have a unit circle, and let's just try and draw my best possible diagram here. And then go across that way. And then they're connected like that. And we're going to have radius there. That'll be my theta. That's y. And this here will be x. So my sine of theta equals opposite over hypotenuse, which is equal to y over 1, which is equal to the y coordinate. It's equal to the y coordinate. The cosine of theta is adjacent over hypotenuse, and we just figured all this out, but I'm just writing it again, so it's the x coordinate. And now an important thing that we probably remember, and I'll put this in my galaxy to remember this for later, okay? The sine of an angle A is equal to the sine of 180 take A. And for the cosine of A is equal to negative cosine of 180 take A. So let's say, for example, the sine of A is 40. So sine 40 is equal to sine of 140 because A would be 40. 180 take 40 is 140. Cosine of 40 would be equal to negative cosine 140. They're going to be really helpful when we get to some identities as well as some difficult types of trig problems, and they're going to be helpful when we get to trig proofs as well. So keep those